In this presentation, I'll demonstrate Tesma and CATG, which are automated test generation tools for models of enterprise applications. Tesma is a model-based testing tool developed at Entity Software Innovation Center, and CATG is the next generation concolic testing tool for Java programs developed at UC Berkeley in collaboration with Entity. I'll demonstrate Tesma and CATG and their integration. This slide describes the Tesma workflow. Tesma takes as an input a design model which consists of database definitions, business logic definitions, and screen definitions. Tesma converts this design model into an UML activity diagram. It extracts all the paths in the diagram, and for each path it generates a Java program describing the behavior of the path. Tesma then applies CATG on these Java programs to generate initial databases and test data. We demonstrate Tesma using a toy model. The model consists of a screen definition, which is an Excel document. The screen definition has screen elements such as buttons and text fields, constraints on the inputs, and the user events. The model also contains a business logic definition document, which is a Visio document. The document describes the business logic in terms of a flowchart. The nodes in the flowchart can be associated with SQL queries, and the transitions in the flowchart can be guarded with predicates over the variables in the document. The model also contains a database table definition document, which is an Excel document. The document contains the schema of all the tables that are used in the model. Tesma is implemented as a Eclipse plugin. In the plugin, we specify the directory containing the input model and the directory in which we want to generate all the test cases. On the push of a button, Tesma converts the input model into an UML activity diagram, extracts path from this diagram, converts each path into a Java program, and applies CATG on these generated Java programs to generate test data and input databases. Here is an example of a test case that is generated by Tesma. The test case is an Excel document. The test case contains a database table. In this case, it has 3 rows. The first column of this table is the primary key, and you can see that each row in the first column has a distinct element. We next demonstrate CATG on a simple Java program. This is a sample Java program. Here we define the 2 inputs to the program, and this is the line we want to reach. We call catg on the file from command line. Catg generates 3 inputs. The second input prints the error string. Catg is configurable. Here we configure catg to print a trace of bytecode instructions and the constraints it generates. Now if we run catg, it generates a trace of the bytecode instructions that it executes and the sequence of path constraints that it generates. This is useful for debug. This program uses a library that models a large subset of SQL queries. So we first define a table with 5 columns, and then we insert 4 symbolic rows to that table, and then we call this function test_me. The function test_me executes a select command. The size of the result set, if it is larger than some threshold, we print this reached goal statement. If we execute catg on this program, it generates 625 inputs. This shows the path explosion. To tackle the path explosion problem, we add annotations. CATG skips symbolic execution of any code between the begin scope and end scope annotations. The red variable annotated with abstract bold is treated symbolically by CATG. With the annotation, CATG only generates 24 inputs. CATG is open source and it is publicly available from this GitHub URL. Thank you.